Hi, today we're going to talk about a little bit about some elements of the course, and let's cover some brief introduction. So, without further notice, let's have this small presentation. The course is called Simulation of Discrete Events. My name is Jorge Alberto González Mendívil. If you want more information about me, you can use this QR code. The learning goal for this course is to learn simulation techniques for stochastic and discrete processes with the intention of using them as tools for decision making. The main goal here is to use simulation and as a tool to improve our models of decision. Here's the evaluation. You can stop the video here if you want to look better how the course is going to be evaluated. Also, these are the textbooks. Some software we'll be using. In the first part of the course, we're going to use the GPSSW. Here's a site where you can download it. It's a freeware. It's your responsibility to download it and install it. And any problem you have with the installation, you can solve it with the Informatica department here at Tecnológico. If you're later in the course, we're going to use ProModel, and you need to buy the book of Eduardo Garcia Duna to have the software. The academic advice is going to be Mondays and Thursdays from 11:30 to 13 hours, and from 1600 to 17:30. My office is 250806, excuse me, AI. There's a YouTube channel where you can see some videos of explanations of the topics of the course, including this video. We still don't have the dates for the partial exams, so as soon as I have them, I'm going to upload them to Blackboard, and I'm going to send you an email with them. Here are most of the topics that we are going to cover through the course. This is the first homework. We already talked about this last class. And let's start with the main topic of the course. First, we are going to be working with systems and with models. And models are going to be the artificial representation of those systems. A system is an interrelated set of elements. Those elements can be objects, parts, processes, features, etc., with the intent to obtain a common goal. This is really important. For example, if we are going to simulate a Starbucks facility, we need to establish which is this main common goal. Many of you can say that the main goal is to get a better income from our clients, and we can be okay with this, but it's not the only common goal that they have. They want to attend as much clients as they can in the less time possible, so they can attend more and more clients. And of course, attending clients, giving them a quality service, a quality product, it's going to get them to have this income, this interesting income that make them productive and competitive. There are some discrete systems, there are some continuous systems, and when we work with a simulation process, we need to extract a model of the process. And this model is going to be an abstract representation of the system. It's a simplification. It's not exactly the system, but it's a very good representation of the situation that we are observing, of the process that we are observing. A model, we can use a model as a design tool to predict the performance of a new system, for example, or as an analysis tool to predict the effect of a change in the system. Either way, simulation is a very good tool to use in terms of this objective. Simulation, for simulation, we are going to use mathematic dynamic models that in terms of numeric representation, and they can be deterministic, stochastic, continuous, and discrete. We have all of these characteristics, all of these features in the system that we are going to be simulating. There are some features in a simulation model. We need to identify each of these 8 features to know that we have a good idea of what we are going to simulate. For example, first of all, we need to identify the entities. The entities are the representation of the entries at the system. Is the responsible for changing the system. Continue talking about an Starbucks facility, we can safely say that clients are the entities, are the representation of the entries. A client arrives, and then the process of Starbucks starts right there. If we are talking about a gas station, we can see the cars as the entities that are responsible for changing the system. Another feature is the state of the system, a condition that the system has at any given time. If I were able to take a picture of any facility, a gas station, a movie theater, a supermarket, there will be set the state of the system. We can observe how the systems look at any moment in time. An event, it's another important feature, and it's a change on the actual stage of the system. Mostly, the entities are the ones that change the actual state of the system. But not always. We also can have facilities. For example, if I were simulating a bank, if the internet is not working well, that's an event that changes the actual state of the system. Uh, if it were a gas station, a malfunction of the equipment can produce a change in the system. Also, as simple as the arrival of a client change the state of the system. For example, I have 3 people waiting in line to be attended at a gas station, and when a new one arrives, now I have 4. So that's a little change in the system. There's also the locations, and the locations are the physical elements where the operations take place. The physical elements as physical space. In terms of Starbucks, the space defined for people to be standing in line, it's a location. The place where they prepare our coffee or our food, it's another location. The place where I take my coffee, where I drink my coffee or eat my food, it's another part of the location. If we were simulating a restaurant like a McDonald's facility, the parking lot will be a location, as well as as I just mentioned in Starbucks, the space for waiting in line, the space for the cashiers, the kitchen, and the space for eating, and all of that are locations. The attributes are features of an entity that are useful to differentiate entities. But in terms of the process, the attributes that are going to be important for us are the ones that represent the entity and help us simulate our process better. For example, when we simulated the arrival of trucks at the Veracruz port, the longitude of the trucks were very important because well, the port was able to attend as much trucks as the space was able to storage them. So that's an attribute that it's important. For example, if I go to a cafeteria My age is not as important as what I'm going to be buying. That's a different attributes, one that it's important and one that it's not. The cafeteria does not care about my age, but it cares about what are my needs, the things that I'm going to be buying. If I'm going to buy a coffee, if I'm going to buy scrambled eggs or a hamburger, that's important because they need to be prepared to give me the service that I'm demanding. Another feature is the resources. The resources are the devices different to the locations that are needed to accomplish an activity. For example, the software that you need to perform an activity, a computer, a laptop, the pump in the gas station, the cashier machine at the Starbucks. Those are resources. The people that is attending you are a resource. Not only it's important to have the equipment, but also it's important to have people to have the complete service. There are also variables that are the conditions that are created and modified by logic relations or mathematical expressions, and they either can be continuous or discrete. For example, the time between arrivals of our clients, it's a variable that we need to define to have a good simulation process. And this time between arrivals, it's a variable that it's represented by a probabilistic distribution. Also, the number of people arriving, it's another variable. The time that it takes for them to take our order, the time that it takes for the client to order, those are variables that are important in a simulation process. And finally, the clock, that it gave us the time of simulation. The most important thing about the clock, about the time, it's knowing which period of time has the most demand from our clients, from our entities, and that's the period of time when we will be observing the process to get the information about all of these entities, the state of the system, and most important of that, the variables. For example, if I were to go to a gas station at noon, maybe it wouldn't be such a good idea as doing it early in the morning or in the evening, when people uh, go out of their works or their activities, and they go to the gas station between their work and their houses. So that's the period of time where there's more demand of the service. Also, in the morning when we go to our work, there are another peak in the demand because there are lots of people demanding that service. For example, if I simulate the activities in a bank, it will be very important to do it and we say in Mexico in the quincena. The day that where they pay us are days of a peak in the where there's a peak in the demand of the bank service. And that will be it for the features of a simulation model. Now there's an activity that you need to perform. This is what we're going to do in class. You need to define the 8 features for an hospital and an airport. You will be working in groups of 3, and that will be it for this first activity. You need to review chapter 7 of Jerry Banks' book. This is an activity for the final project, just for identifying the main aspects, the main features in this process that you want to simulate as your final project. And consider that for this activity, you are going to identify all these features, and you are going to do it using a virtual reality 3D environment. We talk a little bit about having a 360 picture of the facility that you are going to be simulating, and Using that 360 degrees picture, you are going to identify the entities, the state of the system, the event, the locations, etc. Okay, so now we're going to talk a little bit about random variables. And for that, there's another video in the YouTube channel, and I invite you to review that video. Thank you very much, and that this will be it for the introduction of the course.